Hi guys, now I'm going to show you how to find the rule given a graph of the logarithmic function. So given this graph, so we have our x-axis, our y-axis, our asymptote, which is x equals -2, which simply means that the function will never cross that asymptote. And we have 3 points, 0, 1, 4, 2, and 16, 3. Now, how do I find the rule? So if we are looking for a rule that looks like follows, so log base c of bx minus h. Well, as we've seen, h is basically the value of the asymptote. So we can replace right away h to be the value of -2. So in this case, we don't have a k and we don't have an a. So all our transformations are b and h, and we're trying to find the values of b, h, and c. So we've already found h since h is basically our asymptote. So let's go ahead and write this down. So I have log c of bx minus, the value of h is -2. So since the value of h, here we go, is -2, then the function will look as follows. bx minus -2, so x plus 2. And here we have the beginning of the function. Now, given this, we are now trying to find the values of b and c. So we have 3 values or 3 points that we can use to help us find the values of b and c. So let's take a look at, let us go to the next page. So we have that y is equal to log c, b, x plus 2. And we have a first point that we could use. The points that we had were, just write them here so we don't forget, 0, 1, 4, 2, and 16, 3. So suppose I use 0, 1 as a point. So the value of y would be 1. And there I'm going just plugging in these values. And the value of x would be 0. So technically I would be left with 2 here. Let me rewrite this. So I have 1 is equal to log c of 2b. And now, how do I do this? So again, we've seen another property of the logarithmic function, which shows us that this here is equal to what? This would mean that it is equivalent to saying my base to the power of 1 is equal to 2b. So since I have y equal log ba is the same as b to the power y equals a, I can rewrite it this way. So this is with 1 point. Now let's use a second point. Let's use the point 4, 2. So if x is 4, that leaves y to be 2. So I'm left with 2 log base c b x plus 2. So x is 4. That would mean 4 plus 2, which is 6. So here I'm left with 2 is equal to log base c of 6b. Now again, I could rewrite it as c to the power 2 is equal to 6b. So now I have two different equations with both c and b. So this tells me what? It tells me that c to the power 1 is equal to 2b. So c to the power 2 is equal to 6b. So now if I were to take this, c to the power 2 is equal to, I'm taking all of this to the power 2, which is 4b squared. So that would tell me that c squared is equal to 4b squared. So I have an equivalence with c squared here and c squared there. So I can rewrite this as 6b is equal to 4b squared. And now let me solve this. That would be telling me that 4b squared minus 6b is equal to 0. If we were to find the value here, I have that b, I can put 2b out. So I'm left with 2b minus 3 is equal to 0. And that would mean that either b is equal to 0, so either 2b is equal to 0, or either 2b minus 3 is equal to 0. So if 2b equals 0, that means that b is equal to 0. And we cannot have b equals to 0 because then I don't have a function. I'm taking log of 0. So that is not in our choices. That means that we are left with b equals to 3 halves. So now that I have b is equal to 3 halves, I can rewrite the function. Let me change another time. So I have y is equal to log c of b, which is 3 halves, or 1.5 x plus 2. And we were left with another point that can help us find the rest of our value. Either we use the other point, or we could use what we found before. So we knew that c squared is equal to, I go back for a second, is equal to 6b. So given that c squared is equal to 6b, that means that 6 times 1.5, or 3 over 2. So I'm left with c squared is equal to 9, which would mean that c is equal to 3. And so here I have the value of c, and I could rewrite the function as log 3 of 3 halves x plus 2. And here is our rule. If you'd like, you can use the third point to validate or to check your work. So we had a third point, which was 16.3. Suppose I use that point, then I would have 3 is equal to log base 3 of 3 halves. 16 plus 2 is 18. That means that 3 is equal to log 3 of 9 times 3, 27. And as we know from the equivalence, my base to the power of 3 should be equal to 27, and that is the case. So we have checked that we have the right rule to the function. So it is not complicated. The first step, if we recap, the first step is to take a look at what we know. We have the asymptote, which was x equals to minus 2, and therefore h is equal to minus 2. Plugging that in our function, we already have one variable that was missing, and now we can find our values of C and B using the points that are given above. Next, using the points that we are given, I can just plug in the values of X and Y to have an equivalence for C. Either C is equal to 2B and C squared is equal to 6B. And using that, I can easily use a comparison, substitution, or elimination method in order to find the values of both B and C. And once we found the values of B, we were able to use that value to replug it in one of the old equations that we had and found the value of C, thus giving us both the value of B and C. Once we found our function, we could use the third point to check